Saxon's Calculus, Lesson 67, is about explicit and implicit equations and then inverse functions. So why they take the time to explain the difference again between explicit and implicit, I'm not sure, but here we go. So the implicit column here shows me all of these things are equal to a number or x, and none of them are equal to y. So on the explicit side, if it's y or f of x or h, these are y's again. Doesn't matter whether I'm dealing with logs or basic equations. They're implicit if they're not equaling their y value or the equivalent of a y value, such as f of x, h, and so forth. So if it has the x, the other variable, that's isolated, then we say that it is y as a function of x implicitly. And that is all that they're trying to basically give you in that first section. However, they talk about the trig identities and the fact that it's difficult for students to tell the difference between the explicit and the implicit, or it's intimidating or something along that line. And I'm not sure why they're even getting to that, because that seems fairly straightforward to me. Then in part B, inverse functions, again, they talk about the function machine and how if you're doing inverse, you're basically working backwards. And they give you all of this information on the bottom of 335 about the slope of a function, isolated points 1 to 1. Again, all stuff that is not, I feel, overly helpful for the inverse part of things. So here is all you do for the inverse. If, in example 1, page 337, if f of x equals 2x minus 3, this is functioning as my y, and of course that's the x. It wants you to find the inverse for the x, and then it wants you to plug in 4. So the inverse piece of it is to flip-flop the x and the y. Since this is functioning as a y, we're going to call this x equals 2y minus 3. Now, technically, it's wanting you to solve for the y and then plug the 4 in. Now, I say that you can plug the 4 into the x spot and solve it as you go. Either way, kind of irrelevant. So just kind of following their format. 2y equals, so it didn't move. The 3 moved over to the other side, which made it plus 3 where the x was, and then dividing everything by 2 gives me a half an x plus 3 halves. Then plugging in the 4 times a half is 2. 2 plus 3 halves, oh, I have to go back to a common denominator of 2 anyway. So that would be 4 halves plus 3 halves is 7 halves. And there is the answer for plugging it in. Okay, so this answer goes to here. Now, example 2 says, find the inverse function, plugging in 8, from f of x equals 4 natural log of x. So again, we're flip-flopping the x and the y. So this becomes x equals 4 natural log of y. And we want to solve for the y. So that means removing the natural log. But first, let me divide by 4. So I have, we'll call it 1/4 x equals natural log of y. So now how do I get rid of the natural log? Well, its opposite is the e. So if I e both sides, then I have y, I'm going to write it this way, I just like the y first. So that's killing off the natural log, and then e gets your 1/4 x all right, and then, oh, now we're plugging in our 8. So 1/4 times 8 is 2. So this is basically e squared, and we knew that e was like 2.7. So from the calculator, that's going to give us 7.39. Example 3. If f of x equals 2x minus 3, And the inverse gives us 1/2 x plus 3/2. As in example 1, find the inverse with, I keep losing the problem, f. So you're picking up f and plugging it into the inverse, and then you're plugging in 6. And then they want the reverse. They want f, plugging in the inverse, and then plug in 6. All right, so in our first one, f's equation, 2x minus 3, is going into the inverse. So 1/2 times 2x minus 3 plus 3/2. And then on this one, it would be 1/2 x plus 3/2 is plugging into, so that's 2 times that minus 3. I would definitely distribute this half and get x minus 3/2 plus 3/2. Oh, cancel. So that's just x. And then if I plug in 6, I get 6. And then here, the same thing should be happening. 2 times 1/2 is going to be 1x plus 3 minus 3, leaving me just x, and then plug in the 6. And so yes, we get the same answer of 6 for both. So anytime you are plugging something into its inverse, they want you to understand that you will always get the same answer. Example 4, inverse of 9. If they give you y over 3 equals cotangent of x, and that's the f equation. All right, so we want to inverse it first, so we're going to flip our x and our y. So x over 3 equals cotangent of y. Plug in our 9. So 9 divided by 3 is 3. 3 equals the cotangent of y. And then the inverse of cotangent is basically going to, well, to undo the cotangent, you're going to flip that 3 back to basically 1/3 equals, y. And then, what is the opposite of cotangent? Inverse tangent. So at this point, I would do that on the calculator. So I'm going to rewrite this. I feel like that's getting confusing. Y equals the inverse tangent, because that's the opposite of cotangent for the 3. So on the 1/3. So on the calculator, that's what I would be doing, the 1/3 with the inverse tangent, or you could graph it. They do remind you that with the calculator, it needs to be in radian mode for this to be working well, but the answer you should be getting is 0.322. You could graph the tangent of 1/3, but since it's such a messy answer, I would stick with the calculator, not trying to figure it out. Now, they do throw a part C in here, which is the graph of an inverse function. I'm going to pause while I graph these. So here we have our 3 pictures that they give us. So for this one, it is the graph of y equals 2x plus 2 here, because I'm crossing the y-axis at 2 and a slope of 2 over 1. So I just did it backwards down, 2 backwards 1. Then when I do the inverse of that one, it's the same line, and there will be a place in which they cross, and it looks like it just kind of curved itself from there, but I crossed the y-axis at -1, and then the slope was down 1 backwards 2 if I reverse it, and that's where I get it. So then on this one, this is the graph of the regular curve for e to the x, and then acting as an asymptote line is the line that goes through 0, 0, 1, 1, and so forth. So its inverse is the exact same curve, the opposite direction, for natural log of x, the inverse of e. And then the final one is this slightly messier one, and this one feels a little difficult for me because this is tangent of x, which is your climbing. However, it's laying on its side, and so it doesn't feel like it's the normal tangent curve, but it is if you see just this curve here and picture your asymptotes here and here. Well, the inverse tangent one is its exact opposite, curving the other way on that graph.